Ah. What in the world? Stop it. There. All right, so before break, we talked about similar triangles. And we said, hey, if we have two similar triangles, could be in a weird looking figure like that, could just be in two totally different triangles. Similar triangles. We said, what is true about those similar triangles? A few things. What are in proportion?
The sides.
We said there are sides that are in proportion. You just got to figure out which sides match up based on the way they're named or some kind of information they give you.
The way they're named, or the longest side, the longest side.
If you have numbers, you can just use the numbers. If you have measures of angles, you can use measures of angles. So we said, though, that the sides are in proportion. So I really shouldn't be hearing any other voices. I don't think they're in my head. I'm pretty sure they're not.
Are you sure about that?
I'm pretty sure, because it sounds just like the same two that if I keep hearing them will not be sitting next to each other anymore. Because we've had that conversation. Every class. I'm not going to have that conversation in every single class. At one point, I'm just saying. So you've been tested the other day, and I had to warn you the other day. I'm having to warn you again today. I won't warn you a third time. I was just saying. But, right. Thank you. Shouldn't have to keep doing that with high school kids. So, the sides are in proportion. That's fine, we're right here. Sides are in, that's the first thing we learned. We'll go over more what that means in a minute. Sides are in proportion. What else did we learn?
If two angles are the same, all three are the same.
Well, we're going to get into proving, but once we know they're similar, what's true about triangles we already know. You're proving it. Let's say we know they're similar. All the angles are the same. Not proportional. The angles are congruent. I'll write that in the middle. Doesn't really matter where it is. Angles are all congruent. So here's the mistake a lot of people made on the quiz. That's why I'm going back over this. A lot of people said side so-and-so is congruent to side so-and-so. That is not accurate. I mean, wrong. They're not. Does this side look like it could possibly be the same length as that side?
No.
No. I let that slip if you did it maybe once in one of your explanations. A lot of people did it multiple times. I didn't let that slip. I took points off for that. Even if you did all the math right, you did not explain something correctly. You have to understand. Just doing the math is not understanding. Anybody can plug numbers in once you've done it. You got to understand what the answer truly means, what the content truly means. So make sure you understand sides are in proportion. Again, similar triangles is what we're on still. Everything we do today is all still similar triangles. We're going to learn a new trick, but it's still similar triangles. And then angles are congruent. They are the same measure. So you can say that about angles. Any questions on that? All right, now let's do the problem. So what we learn, my board's off already. Shoot. I'll fix that in a minute. What we learned in the last class was kind of two new things. We said if I have a triangle, and if I draw in a line parallel, it's so far off. If I draw a parallel line to one of the sides, doesn't matter which side, if I draw a parallel line, it creates a unique relationship between the segments that it splits. So when I draw that line right there, it creates some segments. That segment and that segment. That segment and that segment. The relationship is, and this is the review from Monday, so you should all know this unless you weren't here. The relationship is not all, first of all, it creates similar triangles. If they're parallel, we went over that before. I'll do it really quickly. Those are similar triangles because we can use angle, angle. The top angle is congruent to itself, and then because those are parallel lines, we can say these angles are congruent. And again, still because they're parallel, we can say those angles are congruent. We did that several times. I'm not going to go back to a more detailed version of that. So again, if those two lines are parallel, we can say they're similar triangles. If they are similar triangles, then we learned a new thing. Instead of comparing the little triangle to the big triangle, the parts are actually in proportion as well. This 4.3 is part of AD. This 10.32 is the other part of AD. Those are also in proportion, the same proportion as the other side. So if I created a fraction of 4.3 over 10.32, so again, that's the little segment over the big segment, it's going to be in the same proportion if the lines are parallel. That's 5.8 over 14.5. That's how you solve that problem. You have to create those proportions, solve it out, and figure out what the answer is. What's the decimal? So you can do that part now if you didn't get this far. Figure out what the decimal is. If they are the exact same number, and I mean exact, don't round off. Remember we said if you round off like a repeating decimal of 0.33333, don't round that off to 0.3. That'll give you a wrong answer. You have to put in all the threes, all the way out. What do we get over here? 4.3 divided by 10.32 was what? Oh, put it in the wrong spot. So that gives you 4.16 repeating. You say they are?
There's a 7. It's like point.
Well, it rounds it up to 7. So again, you need to understand how the calculator works. This number is 0.416 repeating. The reason there's a 7 at the end of it on the calculator is because they round it. It's really 6 repeating though. That 6 goes on forever. It never changes to a 7. The calculator rounds it up to a 7 because the display ends, so it rounds it. This is 6 forever. Never changes to a 7. That's 0.4. Those are not the same number. So, since they're not the same number, what's our answer? Yeah, so no, they are not parallel. What's the reason?
They're not similar.
But why are they not similar? That's the answer.
They're not
So
proportional.
the answer to yours would have been they are not similar because they're not proportional. So if you wanted to say, you could say either one, but the backup answer is really they're not proportional. Or you could say the parts of the sides are not in the same proportion, something to that effect. The next quiz is going to be harder than probably some of the quizzes we've taken. The next lesson is, again, I've made it easier and easier. I've given shortcuts to it over the last, as we go through more classes, I've given more shortcuts. So with the shortcuts, it might not wind up being that bad, but I think it's way more confusing than this, put it that way. Make sure you understand how to do this problem and then the next one I'm about to give you, because I am concerned that the lesson that we go over today, that part of the quiz, people are going to struggle on. So make sure you have these down. So again, if the proportion was the same, those lines would be parallel. The proportions were not the same, so those are not parallel lines. We cannot say they're parallel. All right, any questions on that? I'll give you another one still with the same exact figure, same exact concept. It's just the other type of problem you'll see on the quiz. So now, let's say I give you this. I tell you those lines are parallel. So now you know they are parallel, which means they are similar triangles because we could prove that using angle. And I don't know what CE is, but I want to know. Solve that. That's the other kind of question that's going to be the easy question on the quiz. The easy question on the quiz. So try to solve that on your own first, then we'll work it out together if you don't know.
Wasn't there a number there?
But it's a different kind of problem. I took the number away because this is the other kind of problem, where I don't give you a number, but I did tell you they're parallel. So in that problem, I said, are they parallel? Now I'm telling you they are parallel, but I want to know what that number would have to be to make them parallel. Yeah, you're solving for a variable. Yeah. I mean, you could just write CE and use that as the unknown, but whatever, however you want to do it. I normally put a variable there. The book doesn't. Yes, and it's weird. Sometimes they do put a variable there. It's not consistent. So, oh, actually, there are some there. I want you to practice with calculator. No. Use that. You play with that all you want. Please don't make me get. Okay. So that's actually a TV show. No, it wasn't definitely a TV show. I gave you another minute. Shouldn't take that long. This is the easy part of the quiz, so I'm hoping you can wrap that up in a minute. If not, then you've got some practice to do today and Friday.
Explain why
No. If you're just solving for CE, you're just solving. You would never have to explain why CE is that number. Just explain why they're parallel. Yeah, so it's a different, the question is no longer parallel or any of that. The question is just what CE is. So I didn't think about it. The coach was supposed to ask how big he has it. We're going to get some flag football shirts made up by Coach DiMartino that does the print shop thing. If you want to order one, I can show you the design. Actually, the other girls have pictures too. You can ask them for the design. It's in their chat, I think. The remind, I'm sure they have pictures. So if you want to order one, you can order with us too. I don't know if Coach even mentioned it to anybody. So these are a little cheaper. The shirts, the t-shirts are 15. So instead of 20 something, the long sleeve are 22 instead of whatever the BSN was or BNS or whatever. And if you want a hoodie, he'll do a hoodie too. He doesn't normally do them, but he said he would. He did them for 35, I think. So cheaper than the other site. And I wore my hoodie yesterday. They're, as far as I can tell, they're the same as the, actually no, the hoodie I wore was the BSN. Again, it's nothing any different than what he's gonna make for us. All right, so if we know the lines are parallel, this is the only connection you really have to make. If you know the lines are parallel, you know those are similar triangles. Again, I'm not going to show why again. We did that before spring break and Monday. So if I know those are similar triangles, then I know the parts are in proportion. This line separates the left side into a proportion that is equal to the proportion of the right side. So if I want to know CE, I'm going to put a variable there. Then 4.3 over 10.32 has to equal 5.8 over 1. So that is the equation you should have set up. Although there is another one you could have set up that I'll show you in a minute. What is it? 59 point what? 4.3y equals 59 point what? Don't tell me everything. 8.6. Or some of you don't ever write anything down. You just do it in the calculator. So that should have been your next step. Now to solve, we just divide both sides by 4.3. And what is that, like 13.92? Is that what I heard? So that means that segment is 13.92. Just to make sure I could look at my numbers. So if this is 4.3 and this side is a little bigger, this is 10.32, that side's a little bigger, so that makes sense. All right, so here's what people did on the quiz. There was one, now I haven't graded this class, so maybe this will be the class that changes it. There was one question that nobody's gotten right out of all the ones I've graded. Because we hadn't, first of all, we hadn't even learned this yet. This was before spring break. People did what we just did right there. They took this part and put it over that part, which would have worked if we were putting this part over that part. Problem with the question was we weren't. I'm just going to use variables, but there were numbers, I think, in the quiz. Let's say that's X and Y. I cannot say 4.3 over 10.32 equals X over Y. Why is that not correct? If you can explain that, then you're getting this.
Because the Y is not one part of the triangle. It's the internal part.
That's exactly correct. So you didn't understand what he meant, right? I can't make a proportion between, so think of them as similar triangles again. Now go back to just thinking of them as similar triangles. This is a side of the small triangle, right? 4.3. Well, this is a side of the small triangle, so I can put X on top. That part's fine. I'm comparing a side of the small triangle with another side of the small triangle on the top. This is a side of the big triangle. So again, the bottom numbers should be from the big triangle. Y is part of the big triangle. So I can put Y on the bottom. Is 10.32 one of the sides of the big triangle? No, it's part of one of the sides, but it's not the entire side. I can't compare this entire side of the big triangle to only this little section of the big triangle over here. What would I have to do to make that correct?
Add 4.32.
Perfect. I would have to say plus, here, I'll just erase all of it. And so what I just showed you is what everybody did on the quiz. That was wrong. Can't do it that way. I could say 4.3 plus 10.32 and then say that equals X over Y. That's fine. I can do that. But again, can't do what I did before. So you could have actually solved this problem, by the way. We could have done this same concept. We could have said 4.3 over 4.3 plus 10.32 is equal to, so again, we're not doing that. Let's set up an equation. What would I do to set up the equation with the right side if I'm doing it this way? 5.8 is the small triangle, so that's easy. We're always just putting the sides of the small triangle alone. Either on the top or bottom.
5.8 plus 1.
Yeah, you got to add both of the other ones together. That I could do also. If you solve that out, it comes out eventually to be the exact same equation as we got right here. You got to take one extra step, but it'll come out to be 4.3y equals 59.856 after you cancel some stuff out. If you really understand what we did before the break, most of the problems on certainly everything through today, you can do them the old way. So if you were getting all that stuff before break and that just makes sense to compare a little triangle to a big triangle every time, you can still do all of these problems. Any questions on that? And that's the easy section of your next quiz. That won't get you a passing grade, but it'll get you pretty close.
Did you say the CE was?
Oh, I didn't solve it out. What did you? Oh, wait, yeah, I did. Yeah. CE is the Y. 13.9. What did you have the same equation? What was your equation right before you solved? Yeah, if you ever don't get the same answer, you guys need to tell me this. Like,
Is 4.3.
oh, you actually wait. Did you do it this way you did it the first time, or did you just do what I did?
No, I did it this
Oh, so you did do it the other way. That's set up correctly.
way. I did-
Oh,
I did this.
did you add?
Yeah.
And you add these together. Your setup here is fine as long as you have that in there. But then you solve it. So you did some just math wrong with within. I do
I did it
want
with
to.
you, and then I added it.
But you're not multiplying, you're supposed to be multiplying. It's this times this equals this. Yeah, there you go. All right. All right, go ahead, take your pages out and turn to page 101. One oh one. Man. I don't think I was holding anybody, so I'll go with yeah.
Don't let him know. Why?
Because he's answering questions.
Don't lie. Shut up, Frank.
You didn't ask to go to the bathroom.
We'll fight.
I will throw hands. All right, so. Oh, I'm sorry, we already did that. We're on page one. What page did I say?
101.
Okay, we're on 102. 101 was Monday. We did that.
Make up your mind, dude.
I know, right? There. So 102, we're starting there. Learn mid-segments and parallel lines. Is the only thing we're doing to add today. And then you'll practice for about 30 minutes. Although this gets a little tricky when we do the example. All right. So we've done a mid-segment before. Does anybody remember what a mid-segment was or when we did mid-segment? What's a mid-segment?
If you don't make segment, then both the sides are equal to each other.
The middle of a line.
That's a midpoint, not a mid-segment. Midpoint splits a line into two equal smaller lines. But what's a mid-segment?
No, it's not.
Well, mid-segment, you keep saying midpoint. Mid-segment. It has to do with midpoints, but it's
So you take
talking about
the
the
you
figure.
take the corresponding angle and find the midpoint of the corresponding side, right?
Well, it wouldn't have anything to do with angles. So again, we confuse angles and sides a lot. But the second part you said was pretty good.
You connect the two midpoints of a figure.
So again, all a mid-segment is, it's a line that connects two midpoints. So if we take the midpoint, which is R, and I have to fix it for this. I could get away with it on the other part of the lesson. But
I hate it when my teacher.
this is like the 7th time I've done it today. I don't really think that it's my fault. Oh.
My teacher would do it. She
Luckily, I'm strong enough to take criticism. All right, so I know you. If R is the midpoint and P is the midpoint, then RP is a midsegment. That's all a midsegment is. I drew a line from one midpoint to another midpoint. So they've drawn in every midpoint. They've said, well, let's make Q the midpoint down here, which means that is the midsegment. Because again, it's connecting two midpoints. And this is also a mid-segment. So the key on this lesson is not necessarily the word mid-segment, because I'm not going to give you that word. You've got to understand that those are mid-segments. How do you know they're mid-segments? With no words. How do you know?
Because it gives you those two lines.
by the markings. That's what I'm going to give you. You need to understand what the markings in the figure mean. These markings mean I split it in half. 2 equal line segments. So RP, or I'm sorry, not RP, R therefore is the midpoint. Well, same thing over here. I split this side into 2 equal halves. So that means P is the midpoint. And then same thing for Q. I don't know why I circled that. Hold on, I'll give it to you. You can have a seat. Q is a midpoint because it splits BC into 2 equal segments. That's how you're going to have to recognize the midpoint and the mid segments on the quiz. Once you recognize that it's mid segments, that's when you can apply everything we're about to talk about.
What is that?
Sounds like a.
It's not me. I'm talking about that.
Sounds like a. Oh, I wonder if maybe somebody's doing something in there. I don't know.
My ears have this.
Oh, you know what? They may be doing something in the room because I think he maybe doesn't have a class right now. So maybe there's somebody in there doing work in his ear.
They're doing your scales?
I think they're drilling. That sounds like a drill. I'm going to give you the shortcut first, and then we'll go back and explain why it's true. So a lot of you are not going to get what I do after this. So you need to make sure you have this shortcut down. I hate shortcuts, but this is one of those exceptions when I am giving you a shortcut for it, and I am going to allow you to, I mean, not that I can prevent you, but I'll give you full credit on some of the problems for just using the shortcut. Just because a lot of you are not going to get what we do after this. It's just challenge. It's challenging. I'm not saying like no. It's just it's tough. It's one of the more complex things we've done in a while. All right. So if we have mid segments of a figure, and if we're trying to figure out the sides, like what's the length of one of the sides, either the mid segment itself or maybe the length of the bigger triangle. There's only 2 ways you do it. That's it. That's the shortcut. You're either going to multiply by 2 or still multiply but by 1/2. It just depends, am I going from a little segment to a big segment or from a big segment down to a little segment? Here's the process to do it. Let's say I knew what RP was and I wanted to know BC. I always have to use the lines that are parallel. So make that note. You have to use the lines that are parallel. RP is parallel to BC. So we would then, if we needed to know RQ, we would use AB. So here's what is the relationship. The mid segment is half the length of BC. Or you could say BC is twice the length of the mid segment. That's why when we're trying to figure out the numbers, we're using those. So again, the mid segment is half the length of the parallel side of the bigger triangle. So again, if I wanted to write all the sides out, RQ is 1/2 AB. Or I could have said AB equals 2 times RQ. So it has to be the parallel lines. And then you just have to know, am I multiplying by 2 or multiplying by 1/2? Kira, please put the phone up. It's the last time. I'm not going to do all 3 of the other ones and set up those little mini equations. I mean, you do the same thing with all the sides. It's all the ones that are parallel. So RP and BC are the parallel. AC and PQ are the parallel. You could create the same types of equations with those. We're going to practice some problems, so I think by the time we finish the problems, you'll figure it out. You need to see at least the first example, and then I'll let you go. So now, here's the bigger explanation. This is the part that I might lose you on. Hopefully not, but it's very possible. This is a little tricky to understand. The reason that it's those relationships, either 2 times or 1 time, let's think about similar triangles again. I'm only going to do it with one. So if this is parallel right here to this, those are parallel. What does that mean? What's important about me saying those are parallel?
Similar?
They will, but that's where we're going with that. Because they're going to create a bunch of congruent angles, we already know A is congruent to A, right? So I'm going to outline a couple triangles. That's the little triangle. That's the big triangle. I already know A is congruent to A because it's the same angle. It's part of both triangles. It's got to be equal to itself. But because these are parallel, I can say that's congruent to that. And I can actually come over here and say that's congruent to that. They don't. So there is a proof behind how we know they're parallel. The only way they can be parallel, the only way we can split them into this, oh yeah, okay, let's go there. Remember, if 2 triangles are similar, what's true about the sides?
They're in proportion.
They're in proportion, right? And if they're similar, then those lines would have to be parallel. That's the only way they can be similar. Well, we get a proportion of, I don't even care what number that is. You can pick any number you want. Make that 7, well, that has to be 7. Make that 10, that has to be 10. Make that 100, that has to be 100. They're the same number. So we're always going to get a ratio of 1 on this left side, right? Well, again, same thing here. Whatever number that is, that's going to be the same number. So we're also going to get a ratio of 1 on the other side. That's part of the proof of why they're similar triangles. The sides are in proportion. The proportion is 1 on both sides. So that's another thing. That's how we know that those lines are parallel. So it's because they may not give you that the lines are parallel. They may just give you the markings, and you have to be able to explain why the lines are parallel. And by they, I mean me. I'm going to give you that on quiz. And you got to explain how you know the lines are parallel, or how you know the triangles are similar. In that case, it all similar triangles always comes down to proportions. That's what you got to remember. All right, so now let's go ahead and say a little bit more now that we've kind of proved that they're similar. Once we know they're similar triangles, so again, this triangle here, we just proved is similar to the bigger triangle. We can say a whole bunch of things are true. We already know that these are 3 and 3. We know that's 2 and 2. We know, what would the length of RP be? Think about, don't yell it out. I want you to think about it first. Let everybody think about it. We can put some more markings in. We don't have numbers, but we can put some markings in. So if you need to look at your book pages, if you can't see that figure as well, I'm not going to zoom in because I've already drawn stuff in. It won't zoom out. So look at RP. What do you know about, based on what we just said? Just gave you a shortcut that I'll let you use on this. Think about what you know about RP. I'll let you answer in a second. If I wanted to go from, let's say I knew what side BC was, and I wanted to go down and I wanted to figure out the length of RP, what would I need to do to side BC? Scott, what would I do?
Isn't it like 2 times bigger than
So what would I do? If I knew, let's say I'll give you a number. BC, from there to there,
RP is half of BC.
is 10, right? So what would I do? I divided by 2 or multiply by 1/2 is what I said.
So it'd be
So now that I don't have any numbers, now let's say I don't have any numbers. What is RP now? What can I do? I can't put a number there, but I can put something there.
Parallel mark.
It is parallel. Well, I could, but I want a different kind of marking.
The lines.
I can put the 3 lines because
So a
Since
few people
the
say,
two
I heard a few
sections
people
of
saying,
the
I just
way.
didn't want to say anything yet. If I know this is 3 and 3, right? I know this is half of that. So then that has to be 3. Because again, basically I'm just dividing this in half to get that. Well, half of, and again, the fact that it's 3 and 3, you don't really use that as a number, but it kind of works. I just know this is equal to 1/2, and I know this is 1/2 of, like, CQ is 1/2 of BC. Well, I also know this is 1/2 of BC, so they're equal, they're the same. I can do that with every side of that inside triangle. I know this side here is half of AB. Well, then that means it's 1 mark. I know PQ is half of AC. Well, that means it's 2 marks. So if you'll notice, I got the same markings everywhere in that triangle. Oh, you didn't even. I didn't do that on purpose. As far as you know.
Or your hand motions are too.
So, I loose grip. That's how you swing a golf club. You can't squeeze the golf club. You can keep a loose grip. Loose grip.
Does.
Oh yeah, oh yeah.
Golf
Can't squeeze a golf
club?
club.
Oh,
You
no.
can't squeeze golf clubs. You actually hit it way farther with a loose grip because you can generate more whip. That's a whole nother lesson. So, if I have those markings in, can anybody tell me something about that figure now? What did I just create? Or what, I didn't create it, but what's true? What?
5 triangles.
There are 5. What's true about 4 of them? They are congruent. We have 4 exact same triangles. Now, they're rotated. They're not all oriented the same, so you can't necessarily see it immediately. But remember, one of the ways to prove triangles were congruent, just like similar, but if all the sides were the same length, then they were the same triangle. They were congruent triangles. These sides are all the same length. 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. Those 4 triangles are all the same triangles. You'd have to figure out which angle matches with which angle or which side matches with which side, but they are all the same triangle. So that's the last piece, and that's the biggest understanding piece. Like, there will be some math around that when you do the problems. So we'll do the example. Any questions? Again, if you're not completely getting that, it won't kill you on the quiz. It's gonna be tough to probably get an A on the quiz. Probably certainly get a C, maybe even a B.
It makes sense.
All right, so let's do the other, or not the other, the 2 examples real quick. I'm sorry, 1 example and then 1 check, I guess. We're not doing those other, we'll do those other 2 theorems next class. So look at the next page, example 3. Should be pretty easy using the cheat sheet version to do it. So try to do, I want you to solve, so they want you to solve for DE, but I also want you to solve for AB. Actually, no. I want you to solve for those 2. So I'll let you try, and if you get done with that and I haven't started, you can do the, go ahead and move on to the check. Let's see. Several. I'm gonna let Kira go real quick and you do the next row. I want to see you do this. All right, so please be quick because he's waiting on you. I don't think I've ever had any issues with you.
Never.
I really don't remember.
You really don't?
I was gonna say I don't think I have. So I need you to try that problem. I like writing stuff in the figure, so if you want to try to, although there's Yeah, there's stuff you can write in the figure. There's actually a lot of stuff. Oh, yeah, yeah. I thought you said phone call. You done? Ah,
Yeah, can I hop on that one too?
so you guys gotta remember then, so Burrell, Sky, Henry, and then Riley,
I
right?
just know that I.
But I used to make people finish the problem. Or I'd have people race, finish first and do it.
Always practicing that.
Nah, bro.
Are we taking a test today?
No, test is on Monday. Yeah, if you're done with the other one, might as well. I'm not going to finish the check. I'm just gonna kind of explain it. I'm not gonna do it, so we'll go ahead and get it. It is one of the ones that I want you to do for the quiz. I'll give you another minute. Again, if you're done with the example, do the check problem below. It's especially using the cheat sheet method I gave you. It shouldn't take you a super long time.
It's page 103.
Yeah, that's page 103, example 3. And then I'll tell you what problems you're responsible for from this particular lesson for the quiz. Actually, the last 2 lessons. That's correct for that one. So now we got E. Give 30 more seconds and we'll work on it. Oh, that's super old there. Wow.
Oh, wait, that's all.
Where's my?
No, that's.
Huh. I used to have a thing that showed.
It'd be 1/2 times 15.
Oh, I don't have it.
Is this all the
Pull. Oh, why is he?
It's for you.
Yeah. Hmm.
You still got those cheese and crackers? More?
Cheese?
That's peanuts?
Oh no, they never had cheese. They have peanut butter.
Oh,
That's all I've ever had. I've never had cheese.
yeah. Appreciate you.
Mhm. All right, so again, using the cheat sheet method, this is pretty simple. If I want to know what is DE, what do I need to do? I find what? DE, I need to find
The parallel
the
line,
parallel line.
which is 15.
So this is the parallel line. I either multiply that by 2, or I multiply it by 1/2, or divide by 2 is the same as multiplying by 1/2. So what do you get? Got that one done. Now I could also say this is 7.5, that's 7.5, which means this is also 3 congruence marks. What about DB? Again, what line is parallel to DB? You have to go with FE, because DB is really just part of that.
You can eat secret.
So you can't use AD. You got to think of DB as part of this and compare it with that number there, the 9.2. Does that make sense? Because this is parallel to that. So what do I do to go from 9.2 to DB? Pharrell, what do I do to go from the 9.2? I want to solve for DB. How do I get there? I know the lines that are parallel now. Riley just can't help talking about it. He just can't. So 9.2 is FE. I want to know DB way over here. What do I do?
Always talking this.
FE is half of AB.
For real. No assistance. He's not allowed to phone a friend. So you think I divide 9.2 to get to over here? Hmm? So I'm going from I want to make this smaller. Because dividing is going to make it smaller. So you think 9.2 needs to be smaller? We said we're either going to multiply by 2 again or divide, but I want 9.2 to 9.2 is in relation to AB. I compare even though I need DB, I'll get there later. I can't skip straight to, I mean I kind of can, but I need to do something to this to figure out AB first. Yeah, we need to multiply by 2, which gives us AB. Is that you can't focus?
Yes.
18.4. Now, if I know this is the midpoint, right? D is the midpoint. What would DB be? DB be. If I know this is the midpoint, D is the midpoint of 18.4, right? What do I do to find out DB?
Multiply by 1/2.
Shh. You guys are killing me. Like sometimes you won't say a word, and sometimes I can't shut you up. So we would say, again, there's a shortcut to this, but I want to make sure you understand. This times 2 is the whole segment. But then, because I have the midpoint here, these have to be equal. So I then divide by 2 again. So that would also be 9 points. All right, you can go ahead. Wait, who's that? Oh, if you got an emergency, I don't have a. Yeah, if you gotta go, just go. I'm not gonna do that. No, she gave me her phone. She's out, but he's been waiting. So wait, that actually might be her. There we go. So you can grab the pass from her. Good timing. I was letting him go anyway.
At your door.
Oh yeah.
You should put a
All right, go ahead. I'm not gonna do the check at all. You should know how to do that check problem. The only halfway difficult ones, I think, are C, G, and AH. The other 3 are super easy. Now that I didn't give the first class the shortcut, I don't think, or I didn't give it to them until later. I don't even remember. So go ahead, do that. It's in your book. I'll leave that up for a second. Then I'm going to put the book pages up for anybody that doesn't have the pages. Michael, you check and see if you have it. If you have it, you might have it.
You need to get a piece of paper and like a tape and just put doors and lock full handle.
Well, I can't do that because I'm not supposed to do it. I don't want to advertise because it's a safety thing. What if a shooter came in with a gun and said, "Oh, great, I can get out of room."
Well, you just take it off.
I wouldn't be able to take it off before the shooter got in. How would I know the shooter's out there?
Announce it, just like open it up, take it off, you know.
What if we're the first place he hits and they announce it after we all get shot? How's that gonna work out?
Or you can put it in the inside of the window.
And they're not. It's gonna be locked as far as they know. They're gonna turn it and be like, "Oh, it's locked." Hopefully, I mean, maybe they think about pulling it. Maybe think about pulling it. You don't think so? Yeah, but I have kids that know it's open and they still turn it and then knock on the door because they don't think they can do it. All the time. You guys do it all the time. So I'm pretty, well, I mean, my kids. Like literally, you just did it a second ago. You forgot. So I guarantee you somebody else might not think to just pull when they feel that it's locked. Because they probably do it real soft. They probably wouldn't like try to bust me. They probably just test it really quick and see if it's locked, looking for open doors.
Oh no, you lock it from out there. Like, you can't.
Go ahead, make sure you have anything you need from that. 'Cause I'm about to get rid of it and put up the book pages and tell you which problems it is. Not necessarily in that order. Actually, I'll freeze that. I'll go ahead and by the time I find what I'm looking for, I'll be done with that page. So make sure you have whatever you need there. Oh, let me. Actually, no, I still want to record this.
Did it have to stick?
Oh, I didn't want. All right, so for the recording, those are the problems you guys are expected to know from these 2 lessons. And if you don't have the book pages to know what the problems look like, you can use the online book first of all. But here are the practice problems that I just put up there. Those are the first 8 practice problems right there. That's what you need to know.
Mr. Gill?
I bet everyone can see.
Hold on just a second. Let me stop the recording and then I'll